Oh, I don't want continuous play.
Gotcha. CRISTOPH. I know your last name. What's your affiliation?
No.
Labyrinth.com.
Myself.
None
Myself.
Inc. I got it. I made you an incorporation. I made you a corporation.
No, there's two of them. The other one's in the back.
No.
So if we sign twice, Spencer, do we get counted?
As long as you're not meeting in a closet, so.
Okay. Well, there's a right hand and a left hand, right? You can,
Tom already signed it. Jesus.
I mean, yes.
You can see it, probably.
All right.
Is anyone on the Jabber? Is that
Spencer is, it's underneath him, right?
that's I think
Yeah, that's, if they're there, they're,
on Jabber too?
yeah.
Oh, okay.
That's one of the nice things that comes along with Medeco is for all the people who's like, I can't figure out how to get a Jabber client to work on my corporate computer or something.
Okay.
It pops up there too.
But will if they type anything, will it pop up here or do we have to be on the?
Anybody that's actually in Medeco watching the meeting, it'll be over on the left-hand side. Not there.
Right.
So I guess we're in prog, right?
Oh, hey, it's not me, it's Spencer. Actually, no, whose name is on it?
Wait. Hey. Why?
No.
Let's see.
Ready?
Yeah, you're gonna do the Jabber or am I?
If you can get on it, I tried them.
All right, so
And,
let me find. Does not. I can't find where it went. No, I don't want to update.
okay, let's get going. Good morning, NFS version 4 working group. Brian Pulowski, co-chair. Spencer Shepler is remote. And Tom Haynes is doing all the heavy lifting over here as secretary. And the blue sheets went around. Everybody signed in. If you haven't, wave your hands wildly. And can you go to the?
Yeah.
I don't care. That's fine. Oh. Next slide. Don't. When you registered, you read a note well. Everything you say in here is recorded, even if you're remote. So please read the note well if you didn't read it when you registered. Next. Did you move it? We're going to move Christoph first.
Oh, well, I don't have this edit rights on this.
Never mind. The only change to the agenda, we're going to move Christoph first because of a collision on some meetings. Any changes to the agenda? Is Novak? Yeah, Novak's on. Okay. Who else? Chuck's here.
Yeah.
You're here, and Andy's here. Yeah. Perfect. Okay. Let's start with Christoph.
Did I get his slides?
Thank you so much. I'm going to see if you actually show up on anything.
Oh, sorry. Doesn't remember from my last.
We're on the last one.
Sounds good. No, it's not the outer limits, really is.
So you have you're in order now. So this is the first one. Yeah.
Yeah, well, the first one is the overview one, but that's the first real one. Yeah.
Okay.
Anyway, I need a little heads up that people can see or hear me remotely.
I can't get on Jabber with mirroring. Can someone?
I don't remember how to do it.
Yeah, this is.
Last time I did was like 2 years ago.
Just trying now. It's all Meet Joe these days, seemingly. Okay, so. Hold on. Oh, kill me now. Start, Christoph.
Yeah.
All right.
And sorry, I'm just trying to get to the.
All right, so quick talk about the NVMe mapping for the SCSI layout. So for the intro, basically, we need to take a little step back and look at the PNFS SCSI layout draft, which I started last year as an enhancement or replacement for the block layout RFC, which kind of is the same thing. The data path takes advantage of modern technology, aka being able to identify devices at the protocol level and being able to fence at the protocol level using previous resolution. And last year in Prague, we had a little discussion on that. If we want to do this as something specifically tied to SCSI or to figure out another very generic wording as the block layout type, the consensus was it's much, much better to tie to SCSI because that way people actually have a chance to understand the details. And the draft's been going pretty well. We had an ISG last call 3 weeks ago. I got a couple really useful, really late comments from Dave. And well, now we can move on to NVMe. So the thing that this draft tries to deal with is NVMe devices. And NVMe used to be spec that was just for TCA flash, but usually flash, any other kind of non-volatile storage by the name or any kind of storage by the way it actually works. And since the 1.1 version of the spec, right, should I restart from the beginning or?
Do you want to?
I don't care.
Sure.
So go back. All right, NVMe mapping for SCSI layouts. Look back to the SCSI layout itself, which started as an enhancement / replacement of the block layout that fixes a couple of the issues with a protocol that were very hard to actually implement in practice by taking advantage of modern technology, by being able to have a unique device identification at the protocol level and being able to actually securely and agnostic of the actual device being able to fence misbehaving clients. And per our discussion in Prague last year, we had the consensus to specifically tie it into SCSI because that was the only protocol viable for that last year and the major protocol viable for it still today. And that allows to specify it in a word that actually, in a way that actually references the SCSI protocols, as in making it actually understandable for mere humans. And we had an IESG last call for that 3 weeks ago, a couple comments that were very useful coming in later that should be addressed soon, but in general, it's making good progress. So the other thing that kind of came up already somehow around that time, but even more urgently now, is that we have multi-host aware NVMe devices. NVMe was traditional spec for PCIe devices that address usually flash storage, new command set. And since that version 1.1, the interesting thing about NVMe is that it also allows what SCSI people would call multi-initiator support. NVMe people call it something else, just to be different. And so when you have multiple connections to the same namespace, which is like the logical unit in SCSI and so on, we support the concept of multiple controllers. We already have useful device identification, actually only since that 1.1 version of the spec, and includes a version of SCSI persistent reservations that is extremely similar to SCSI with a few enhancements and a few things like that. And these multi-host PCIe devices, this was done initially, mostly just exist in labs so far. So they're really kind of niche that at this point isn't very practically relevant. Hopefully it might become at least a little bit relevant sooner or later. But the thing that is really interesting is the NVMe Fabrics protocol, which basically is starting to look like the initial fiber channel protocol. So we take the NVMe command set separated from the physical layer and allow to transport it on top of other protocols. And the protocols we're doing that is RDMA, as in InfiniBand, iWork, Rocky, and so on, or fiber channel, like the old SCSI fiber channel.
Okay.
And because the feature set is actually, well, in the area we care about, easily mappable one-to-one or almost one-to-one, as they pointed out. What I wanted to do is to be able to specify a way to reuse the SCSI layout with NVMe instead of creating yet another layout. And the one document that really helps us a lot with that is a document published by Express as well, which is the SCSI translation reference, which basically tells you how to do a conformant SCSI implementation that uses NVMe as a backend. And so what I did last week, I think, was to publish a new draft on using the parallel NFS SCSI layout with NVMe. It's a really tiny document that basically just says where to look in the NVMe STLR for the features that the SCSI layout uses. And because it doesn't really contain anything normative, I've published it as informal. We might talk about the correct decision a little later. And one thing Dave pointed out is that the fine points of persistent reservations in a multi-path setup might actually require some normative things we have to do in that document. unless we get it on a different route and try to fold that back into the NVMe document. Well, I see someone disagreeing there, so we might have to do that in our document instead. And that's pretty much all I got for now.
Go find mine, I hope. Stay out of the mic. Okay, so this, actually, BB's mic is the only one that's working right now.
Really?
Yes.
All right, so what all right, I will stand in the box. I saw the infamous "you didn't stand in the box" slide. I think it was Honolulu. Fine. David Black. The finer points are that, in fact, NVMe has actually done a better job of integrating persistent reservations with multipathing than SCSI did, or at least that's what my multipathing people tell me. However, no good deed goes unpunished. And one of the good deeds that gets punished is that one of the bits that Christoph is using to get the persistent reservation to apply for multipathing doesn't cleanly translate across SCSI and NVMe. That's probably why we're going to need a little bit of normative text.
All right. Sorry, I can't help but observing. We are successfully remotely having a working group with no local microphone access. Okay, so now, except this one that I have. So Christoph, you're done. Thank you, David. No, there's, I have my people in the room fixing the audio. Okay, next. Sorry. Oh, circling back to the beginning. Andy, the IANA editions. And
All right. It sounds like it's working. Yeah, it's back to you.
yeah, try it.
Yeah, so
Okay.
during the Auth 48 review of the RPC-SEC GSS v3 draft, Nico pointed out that we really needed a namespace for structured privileged names. We went back and forth a bit and came up with an IANA proposal to add this to the spec at the last possible minute. So we went back and forth. It sort of took us out of our normal process of going through the final stages of the RFC. We went back and forth between the IANA group and our group trying to figure out what to do. As of this point, we've had a GenArt review, comments folded into the latest doc. IANA has a copy of the spec that was pre to the last comment, which added one sentence. So at this point, what needs to happen is when the ability to upload new drafts comes back up after this meeting, we will have the new draft loaded in, unless there's some other way we can do it. And then we can move forward with the final stages of this draft. I think that's all, unless there's questions.
Questions? Sorry, I'm talking on the chat room too. No questions remotely, no questions locally.
Spencer.
Spencer?
This is Spencer Dawkins. The draft submissions should be open as of Monday morning this week.
Oh, okay.
That's like a new thing, but
Oh, because I was just following the important dates.
yeah,
So, all right, I'll submit it then.
yeah.
All right.
Cool. I'm trying to remember when that started, but drafts started magically appearing during IETF week a few IETFs ago.
Oh, did they? Okay. Having not had that experience, I didn't know. All right. Good. Then I'll do it immediately. Thanks.
Okay, thank you very much, Andy. Dave Novak, you're our first remote
actually, we have the
Wait.
votes and already on the IDs.
That's you, BB.
No, it's not. Actually, I'm going to hand this to Tom, who we were talking about last night.
Right. So actually, it's Chuck, right? Because well, it's past the buck. Yeah. So no, I believe that you had had a discussion with Spencer last night about the availability of your documents to go forward.
Chuck Lieber Oracle. Spencer and I talked about this offline and resolved. It was just some miscommunication between me and him, and I think those documents are going forward now.
Yeah.
If that's okay.
Yeah.
Yes, please. Yeah, and I'm catching up to the chat here while I'm trying to manage a bunch of live people. And Spencer says this is closed. Let's move on. Thank you, the other Spencer. Thank you, the other Spencer. Dave Novak. Wait. Okay. Hold on, we're bringing up your slides, Dave. Give us a second.
Which one is this?
Underneath there.
Nope. I hate this. Have I said I hate this?
Before extensions. Yeah.
Before it says.
Sorry.
I don't know why it doesn't like it today.
I appreciate this.
Client discovery agenda. There it is. So, Dave speaking.
Okay, Dave, we have your slides up. If you're speaking, Dave, we can't hear you, which might be our problem.
Okay, yeah, okay. Now it's
Oh, there you are. Thank you.
it was my problem. I didn't hit the right icon. In any case, I'm going to speaking about where we've been on where we've been and where we're going on the extension paradigm and what the working group wants to do. Anyway, next slide. All right. So the basic problem that we face is the question. We've been living in the minor version world for a long time, and I think at least I don't like it. Lots of other people don't like it, but we've never really made the transition, and we've never really officially decided that we want to make the transition or how we'll make it. So I'm going to talk about those issues and what we might do with the pending extensions we have gathered up already, of which there are 2, and also about some of the working group charter issues I've discovered, and about the decisions that I think the working group needs to make. So next slide. Right. My impression is that when I discuss this, nobody says, oh, really want minor versioning. Everyone says we want incremental extension, we want faster, we want different, you're doing it wrong, or something else. I want to get clear that we're agreed as a group that we want to move away from minor versioning. And I'm not sure if we can make that decision here, but we definitely have to make that decision in some way and go forward on that basis and then figure out how we do it. You know, nobody likes it. We still have it. I think that's a bad thing. And I want to be clear that there isn't someone out there who said, oh, gee, we really want minor versioning. That's the question we have to decide. Is there anybody, maybe not now or afterwards, questions who thinks minor versioning should remain, not as an option, but as our major extension mechanism? If there's disagreement about that, we have to resolve that and get to a consensus about that. So if we do decide that that's the way we want to go, we have to decide how we do it, and that's what most of this talk will be about. All right, let's go on. So,
Actually, Dave, this
Yes.
is Brian BP. No, so my recollection of history was that the first set of proposed changes to the specification violated the minor versioning rule, or at least supplanted the original 4.0 spec such that we broke the minor versioning strategy. Is my recollection wrong here?
no,
we
it's
had to.
it's right, but it was never, but neverly, we never explicitly said that, although what you said is correct. We never said, oh, gee, we broke the rules, we're changing our mind. We actually sort of pretended that we were just slightly modifying them. And we're now living with the result of that decision.
Okay, I hate it when I'm right sometimes, but go ahead.
Well, we broke it in one way, and now we figure out that maybe we broke it in the wrong way, or at least a way that was right at the time, but we don't want to continue with. We don't want another thing like v4.1, but we do want to maybe. Then we went to v4.1, broke those rules, decided that wasn't a good idea. Then went to v4.2, and then we decided we would have a small spec that would be 100 pages and would get done quickly. Unfortunately, it was a small spec. It was it was 101 pages, but it took over 5 years. So we decided that probably wasn't the way to go.
Okay.
So in any case, you know, we have this choice between minor versioning between minor version like v4.1, we've decided we don't want to, or minor version like v4.2, which I sense the people don't like, or do incremental individual extensions. And there's a number of ways to do that, ways possible. One is we could convince the ISG that we have a viable incremental extension path, or we can try moving forward with specific extensions and see what happens, or maybe there's other ideas about that. And then the question is, when do we do that? I've heard some people say, well, right away, immediately, no question. I'd say I'm going to later talk about maybe we should do minor versions until we have a mechanism for incremental extensions approved, or we could do minor versions indefinitely if we're forced to. So that's basically the decision we have to make. We have to make some choices about how we get to incremental additions if we want to go there. Next slide. So we do have an existing working group document, which is draft IETF96-NFSV4 versioning 04. And that's marked as updating 5661, which is the last thing that presented the modified rules that BP mentioned, where we basically said, well, we're changing the rules, but it now says, it then said every version could make its own rules, which is not really a very good idea. In any case, I've had some specific comments about that document from Chuck and Mike Kupfer, and I've addressed most of those, and there will be an 05, but it doesn't seem like we've gotten the broad range of comments that would be good for consider that sort of ready to go. Mike has some concerns about the readability of that document and the structure, and I'm willing to address those. But first, we want to address some general concerns about the strategy, which I'll discuss in the next slide. You know, for example, I have a lot of problems. The document is long. It's as long as I thought it should be. Maybe it's too long. I don't know. Anyways, Bruce Fields started review, but he didn't complete it. He gave up about after 20 pages into it, and you know doesn't give me a good feeling about going forward on this path. Anyway, I think we need to, and as we go forward with this, we need to involve people who have pending extensions and make sure that everyone's in agreement on a path forward. So next slide. So the big issue that was raised at the conference call about extension that we had after IETF 95, or yeah, right. This was Bill Simpson raised this issue. He said he asked that the document be informational because he said that you can't, basically, one standards track document cannot bind the hands of future RFC writers, which is logical, but right now we have a set of rules that pretends or purports to do that, which says that you can only do, essentially says you can only do extensions via minor versions, and that is a standards track document. We treat those as rules. Now we did it, as BP points out, in 4.1 change those rules, but right now it is a standards track document, and I think the problem is that we do have the standards track document that says these rules that we don't agree with, or I think the working group doesn't agree with, and we have to get out of that problem. So on to the next slide. Next slide. Hello?
It advanced.
Okay, sure. All right, so we have an existing document, which is, so how can we resolve this? So possible ways to do it is, with one document, is the standards track document. As I've said before, we have had a lot of trouble progressing that document. And as Bill points out, some of the material, at least, does seem informational. And maybe we might, but it doesn't seem right to me to transition that document to informational, because we do have a standards track document in 5661, which we have some problems with. It doesn't allow extensions outside minor versions. It allows almost anything in, quote, infrastructural features. It doesn't really address non-XDR changes, which is a big problem that was fundamental to this, to our, I think actually when we created the rules for v4.0, we didn't even think about there would be non-XDR changes. And when we when we went 4.1, we made non-XDR changes, didn't really care about them because we were essentially creating a new protocol. And so now it's necessary to have some discussion of non-XDR changes as well. And also we have some things, or basically, I'm not sure there's actually a statement, but we have some accumulated practices that makes it very difficult to correct protocol bugs. And that was one of the main things that I tried to address in the current working group document. Anyway, the problem that we have is that we can only change what is in a standards track document in another standards track document. So I think that at least some of the work that we've done needs to be done in a standards track document. And so on to the next slide, which is looking at maybe having two documents. All right, so the options are. So one option would be an absolutely minimal standards track document. And if I say absolutely minimal, I would simply say, well, look, 5661, whatever it says about extension, forget about it. It's wrong. And just whatever you need to pass ID NITs. But I can't really see the ISG accepting that. It's sort of like the nuclear weapon version of standards track document. So I don't think that would work. So another approach is to have a small standards track document that would extract from the current working group draft the material necessary, the thing that I think has to be standards track, and eliminate some of the informational stuff that is arguably informational. And let's go on to the next. There are other possibilities, but that's the ones I've considered. So I do have an ID out, draft DNOVEC NFSV4 extension 00. Now that's only 21 pages, and it basically has what in my opinion, is necessary to go forward. The ID of XDR extension is as a separate thing, separate from the ID of minor versions. Rules for XDR extension, that you can add extensions within an existing minor version, which I think people want to do. How the client and server can work together even though they may have different XDR definitions. Discussion of non-XDR changes with it and rules for them. Basically, the rule is you have to do that in a minor version, and you should keep it small. That's go against the tradition of v4.1. And also some discussion of how to make XDR corrections to existing protocols. And the remaining piece of the minor versioning rules from 56.1, the rules for interversion interactions. So that's out there, and I'd like any comments people have on that document. Oh, either now or in the future, and we'd go for. Okay, next slide. So the reason this is now a significant issue is, first of all, we're almost done with v4.2, and now, while we've been working on v4.2, there are a couple of extensions that didn't fit in v4.2 that I think there is a need to make part of the NFSV4 protocol. So there are two of those that I know of. One is draft IETF NFSV4 XAdders. It's fairly far along. It's basically waiting for I think it's waiting for a resolution of the extension issue. I haven't heard any disagreement about it, but basically people don't know how it's to be incorporated in NFSV4. That's my impression.
Hey, Dave.
Yes.
Chuck Lever.
Yep.
I've spoken with people who are close to that effort, and they say they want not to wait for the extensions issue. They'd like to see that happen, but I don't know if that's practical, but that's what they've told me.
Okay, well, all right. So, well, my version of it was I can see how they might be getting impatient, and that's what you said is consistent with that.
Okay.
Oh, this is Tom. I'm actually surprised. They're not being active. We're not trying to squelch them. They're just not taking the initiative to try and get published.
That's also my impression, and I remind them when they talk to me about this that they need to drive it. But their impression is that this is
so. Yeah.
Their impression is that this is being held up by
the other one is
work,
this is the
that's
UMass
not true.
thing.
Dave, you seem to have cut off.
I hit the icon again. All right. Anyway, so where did I drop off? Anyway, I'm going to talk about UMass. It's not as far along as XAdders, but it is a very simple extension, and it's also arguably a correction to NFSV4 that could be put into NFSV4.0 if we allowed that sort of thing. And maybe we should be thinking about allowing that sort of thing. All right, let's go on. Next slide. So what are possible approaches? One is go on as we have been and try to get the extension document. As Chuck noted, some people are getting impatient about that and want to go forward, and maybe want to figure out how to go it alone. And that applies definitely, well, not definitely. As Chuck reports, it applies to the XAdders people. My impression is that the people involved in UMass also wants to do that, but they also haven't, although they've gone through to make it a working group document, they haven't pushed for it going forward, but I assume that they will at some point. So I'm going to discuss these possible approaches. What might happen, what I fear might happen or think might happen in the case of trying to go it alone to the ISG without preparation. My impression is that there'll be all these questions about, well, do you update this, do this, you contradict these rules. I think that's why to avoid that was why I tried to create the standards track extension document, but that doesn't seem to be working, so I don't know how to go on. Another possibility is a multi-pronged approach, which I'll discuss later. All right, let's go on to the next slide. So suppose, hello? Hello?
We're there.
So suppose that either the X-Adders people or the UMass people try to go it alone and push for publication. What might happen? They would present the idea what would happen if you presented this as a standalone extension? It's first of all, it's not clear what is necessary if these people push this. What would do? Well, we need some sort of consensus, but it's not clear what the consensus is about. Is it just about the fact that the documents are clear and technically right, or do we need a consensus about on the question of whether it's appropriate or a good idea to go to the ISG at this point? And I don't know if that I don't think that's part of the consensus, but I'm not sure what the right rule is here. I'm not sure what, maybe we'll hear from one of the Spencers or either or both of the Spencers on this issue. In any case, that's one question. If we decide to go forward, what's necessary in terms of consensus to decide that we should pursue this?
Sorry, Dave.
Yep.
This is not your fault. But your audio just went ape shit. So, and this is being recorded, right? Try again, because you were coming in. I was just going to say you were coming in loud and clear, and this is amazing. And you just went south on me. Try one more time.
Okay, from where?
Wow, you're breaking up. What do I do?
Okay, can you hear me now?
Yeah, I would say speak slowly.
Okay. So, from where should I go back to?
All right.
Well, let's see. Basically, the issue that I'm raising is, and I have been discussing, is, well, if we decide to go forward, if the authors want to go forward, we need some sort of consensus. And the question is, what should that consensus be about? And it's hard to get a consensus about things. First is one level of consensus is.
So Dave, maybe if you drop this session and start it over. No, I mean it hasn't improved.
Okay. All right. Let me try that.
By the way, it was going so well. I was thinking, wow, we could do all our meetings remotely. And then as soon as I thought that, yeah, I know.
Okay. Can you hear me now?
Oh, that's perfect. Damn.
Okay.
Good suggestion, Tom. Okay.
Reboot.
I didn't have to reboot. Well, in any case, so we're discussing this issue of what's necessary if the authors decide to go forward without a standard track document. What would be necessary for the working group to have consensus about the advisability about that? Anyway, in any case, let's go on to the next slide. Now, this is my own speculation about what would happen if well, first worry about is probably the ISG wouldn't understand it and it would hang around for a long time because, it would contradict most of the assumptions people have been making about version management in NFSV4, which is why I tried to write a standards track document saying that was wrong. So I think it would hang around for a while. And when and if, even though it would go forward, I can't see it being approved until for a long time. And when the minor version document does get to the ISG, if it eventually does, I think they would insist that you refer to that normatively. And so essentially what would happen is you'd be pushing it forward, but I don't see it getting approved until there's some basis for the ISG to understanding our new approach to extension. Anyway, on to the next slide. Okay, well, while you were doing this, I think the other thing that would happen is people would be developing running code. People would need to develop prototypes of either of those features. And once there was a Linux client implementation, there'll be multiple server implementations pretty soon. And the implementation proceeds on the basis of a generally accepted document, which is at or near the working group last call level. I think that work would go on. And the fact that it hadn't been to the ISG wouldn't really affect much. So eventually, what would happen is implementation would proceed in parallel with the ISG's consideration of that. And eventually, the ISG, once it was out in the world, the ISG would eventually approve it on an as-implemented basis. So that might happen, or even apart from, or so what might happen is several things might happen at the same time without being sequenced. One is development of the implementations, the ISG consideration, and the versioning document. So I don't know in what order they would happen, but I think they would all have to happen eventually. Okay, next slide.
Wait, hold on. David Black's at the sorry, Dave Novak. David Black's at the microphone, and then I have something from Christoph.
Okay, so David Black. So Dave, I appreciate all the thoughts gone into this. I think you're getting a little bit overdone and wrapped around the axle on what the IESG will or won't do. Can we go back and focus on the problem we're trying to solve? BP, could you scroll back to the two extensions that are pending? There's two that there's. Keep going. Bingo. Okay, go forward one. All right. So, question I think that we ought to be talking about is, what do we need to do to move these forward? I assume that these extensions are useful, valuable, and that we want to get them done. And so the question should be, what do we need to do from a process basis to get these done, as opposed to asking, what will the process allow us to do? So let me ask this one. What do we need to do to move these forward? And it looks like X-Adders in particular wants to move fairly quickly.
So the answer is
they don't, because they're not active.
Okay. Well, so my answer to David's question is, I don't know. And the only way that I can think about it is thinking about what might happen if you did particular things. So that's what I'm trying to do here.
Okay, let me suggest what this should look like in terms of docs of docs that go to the IESG without talking about content. To the extent that you need process changes to get X-Adders done, the working group, in my opinion, and this is as an individual, not as anything else, should send the IESG a 2-doc package. Send X-Adders, which is, this is what we need, and package it with a second doc that says, and this is how we got to change the rules in order to do what we need to get done. The IESG, in my experience, is quite flexible about, oops, those rules weren't quite right. What we need to do to get things to work and get to running code is this. Fine, we can change the rules. And the IESG can make all kinds of weird and wonderful process exceptions. So I wouldn't be too concerned about that. I'd be very concerned about, okay, what do we need to do to get X-Adders done? What's the forcing function there in the technical content, as opposed to just the process stuff?
Well, I think the technical content is decided. At least I think, you know, we're now hung up on the process thing. So
okay. So the blunt question to you is, what is the minimum process change that is necessary to get X-Adders approved in a fashion that lays a solid foundation for us going forward?
Well, I think it would be, one approach is, what I think it would be, the minimal is what I've described as this minimal standards track document, which is right now the ID
Let's go
draft.
put that up on the slide, please, so we can see the room.
Which way? This way?
Yeah,
Which,
right.
let's get that slide up so we know what we're talking about.
Yep, that's
Is it
it.
this one?
That's what I'm thinking.
Okay, so if the working group, so sorry for indirection here, but I can't, I don't want to sound like I'm dictating. If the working group thinks that this is the foundation that's needed to go forward, and this is what is necessary to get X adders done, then I'd write this up and plan to send this and X adders to the IESG as one package. I would not send a pure process doc by itself, because that's asking for all kinds of, why are you doing this? To which the answer is X adders.
Okay, sure.
And if that UMass extension wants to come along for the ride, the more the merrier. But I would not send up a process doc by itself. I would send up a process doc, and I would send up the technical change that the technical extension that the process doc enables. And the ISG will have a much easier time dealing with they want to do this and these rules got in the way. Fine, we can deal with those rule changes because we know where they're trying to go, at least initially. And Spencer's sitting here listening to me. He's not taken my head off yet, so I'm probably doing okay.
So while Spencer gets up, to take off David's head, this is Brian BP. I'm leaning to David Black's practical approach over here, Mr. Novak. Sorry, there's too many Davids in the room. It's unusual. I understand that getting changes to V4 in is a challenge. We're trying to do it without disruption and interoperability. So without disruptions and with interoperability, Jesus. And
No, let's
Jesus
do it without
loves us.
What the hell?
What I like about David's suggestion is that if we take one of the documents like XAdders and do a 2-document approach, that we have a proof point of the solution of a problem, as opposed to asking the IESG, who frankly approved our previous approach without a proof, gives them something to show that we're solving a problem with the document. And I think David, I'm sorry, I'm going to put words in David Black's mouth. He could object if he wants. I think David's point is he's not against the clearing up the way we do a minor version, but he thinks that we should show that it's solving a problem explicitly by coupling it to another doc, and it gives information to the ISG in context, as opposed to asking them to approve a process change without any example of what problem it's solving. It's that simple, I believe, is what's been proposed, and I can't see any argument against it.
I agree with it. And if Spencer wants to take someone's head off, he can take both David's head off. But I will stand my ground here. In any case, try to take my head off.
Spencer Dawkins is at the microphone. Spencer.
Spencer Dawkins speaking as AD, and I was actually just waiting for David to stop talking. So before I got up, the 2-document bundle that he's talking about is something that I would be comfortable with sending forward as a bundle. So I think that's a real reasonable strategy. I would mention maybe in support of that. So like every ISG is different, and it seems like the last couple of ISGs have had less patience with process diddling. So which doesn't mean that's not going to change in March, right? So I think that sending forward a process document with no context is probably less likely to be productive. I could see that failing in a couple of or 3 ways, but there's plenty of paths through the woods that are still bumping into trees. So I think that's really good advice.
Okay.
Actually, you can hold me to this. I would be comfortable sending them forward
Okay.
And like I said that, and whoever's taking minutes can minute that, and
I'll note that.
yeah.
Mr. Novak, you're on.
Well, let the minutes show that nobody's head was taken off, and furthermore, David's suggestion has meant that a lot of my slides are now irrelevant. So let's go by those.
Dave, I hate to say this, Mr. Novak, could you rejoin the meeting? That seems to clear up the garble. You just lost it again. Apologies. We're fine.
Can people now hear me again?
Yeah, you're perfect again. I apologize, Dave. The reconnect seems to clear everything up.
Okay, so what I was saying was that in view of David's suggestion, a number of my slides are irrelevant. So let's just go by them. I won't. There's an approach that wouldn't work. I now understand. Okay, so let's go by this one as irrelevant. This is irrelevant. Okay, so the next subject is that we do have some charter issues, as I've noticed. The charter does not cover what we are now doing. It specifies maintenance, but the definition is unduly restrictive. It covers editorial corrections and best practices documents. There's no discussion of technical corrections, which we've done, we need to do. No roles for new features, new PNFS mapping types, new extension paradigm. All of our current working group documents beyond the cluster C283, which is going to be done any moment now, fall outside the bounds of the current charter as I read it. So I think we have to do something about this. And we did a discussion of some of the questions in the next slide. There'll probably be some ongoing discussion of this issue. Next slide.
Hey, David, this is Mr. Novak. I'm sorry, I'm going to call you Mr. Novak from now on. This is BP. Yeah, so my recollection of where we are on the charter was when the ADs decided we needed to put up or shut up and kind of, reduced our playground a little bit to get a document out of us. Spencer Shepler and I will refresh the charter for our ADs and push that up to reflect the ongoing work. It just needs a refresh. Don't worry about that. I do recall why that charter is the way it is.
Okay, so all right, so I think so my opinion, which I think BP and Spencer should take care of, should reflect the opinion of the working group. So let me offer my opinion. Next slide. So things that should be in the new charter is technical corrections like RFC 5666 bis, the SCSI mapping type, RFC 5667 bis, the migration update, UMask, XAdders, new features like XAdders, new mapping types like FLEC files, and I think in general we need a more complete concept of maintenance, including adapting to new file system features like XAdders and responding to changes in technology such as RDMA and higher performance persistent memory. That to me is important to put in the charter. Okay.
I agree.
So decisions to be made. Well, I've raised the issue of, is there any doubt in the working group about the choice of incremental extension as opposed to minor versions? If anyone does have objections to that, They need to say them either now or soon after the meeting. I think we need to understand whether we have a consensus on this issue. Now, regarding how proceeding on their own, I think David Black's suggestion means that this doesn't have, we just have to decide together which we need one extension and some sort of process document, and we'll have to decide which of those goes forward, and those will either two go forward as a package or three go forward as a package. And I think we'll have to in the next few weeks make those decisions about how we go forward. One part of that is deciding whether my current ID is ready to go become a working group document, and I hope that would happen sometime after the meeting. So that's it. That's it for this talk.
Hey, this is BP. Hey, thanks, Dave. If I would summarize, I don't think anybody's has a position arguing against the need to be thoughtful and figure out how we go forward with extensions, and that whatever we came up with for minor versioning before failed on its first try out the door in terms of what we thought beforehand. So I appreciate the comments and the write-up. The charter slide you showed, I thought was very succinct, and I'm just going to talk with Spencer Shepler about using that content to refresh the charter to discuss with our ADs. So I think the next step is just finding one of the couple of extension document owners and going forward with that document and a proposal from you on the process. Is anybody against what I just said? Any nodding heads up and down, remotely throwing stones? I'm being accused by the AV guy of not paying attention. Spencer's laughing. Spencer Dawkins is laughing. I'm trying to pay attention to the meeting, not to the random audio problems. Oh, no, I know. It was the guy. No, it was I think it's our silent lurker of our AV guy who's probably hearing this. Anyway, so thank you, Dave. Okay, and Shepler and I will follow up with you on the next steps. Okay.
Sure.
Okay. Chuck?
I just want to give a 5 or 10 minute overview of what we're thinking about for the next version of RPC over RDMA. Next slide. This is slide 2. Our goals were to keep it pretty narrow. There are some there's some low-hanging performance fruit that we thought we could address with some simple changes to the protocol. But we also recognize the need that there's some larger changes that we would like to work on, but we don't want to hold up a base version 2 protocol for. So the other important feature in this is the ability to make extensions to RPC over RDMA without having to bump the protocol version number, and basically set down some rules about when that protocol version number bump is needed. And then the bottom bullet point on the slide is I think we do have a desire to continue support for a broad set of RNIC and HCA hardware, as well as to continue to recognize the importance of user space, NFS servers and clients, and embedded applications that might want to use RPC over RDMA. Slide 3. So I'm going to talk a little bit about extensibility first, what we're doing here. This slide encapsulates what I said just a minute ago. We're looking at ways of being able to advance the protocol without these major specification requirements and without what Dave Novak has called feature batching, which is The simple features being held back in a large bundle version update by the more complex features. If people want the simple features quickly, they usually get queued up behind large features and everything gets delayed. So I think what we want to do is enable a sort of a parallel development process where the simple features can get right into the protocol as soon as they're mature enough. Slide 4, please. So I kind of took some guidance from Dave Novak and from the way PNFS layouts work. Essentially, you just add a message type in the RPC over RDMA header that's got an opcode field and an opaque data field. And extensions simply define new opcode values for that field and new data types that go in the opaque. Really nothing more than that. And these can be defined in separate documents in parallel with each other as long as the opcode values don't collide. But that's what the working group is for. So slide 5. This is what the XDR looks like. We decided that we needed to have some indication of message direction, whether it's a part of a requester to responder message or whether it's responder or requester message, because we've got forward and backward direction on these connections. So I've added a field in here that is basically the message direction enum type from RFC 5531. That's call or reply. That's the first field. And then, as you see at the bottom of the slide, op type is the opcode field and opt info is the opaque. Slide 6. And then I just extended the body union, added RDMA to optional at the bottom there, and added an RDMA optional enum value in the proc type. Slide 7. And then we added an error code to report when a particular opcode field is not supported. That's inval option. Slide 8. So that's it for extensibility. So talk about what we did with inline threshold. That's the other major change. We have this problem with RDMA read adding a round trip. So for small write and symlink payloads, they need to register the payload and add that RDMA read round trip, and that's pretty expensive. The other problem that has been cropping up is that NFSV4 compounds are pretty big. They're bigger than NFSV3 operations were. So the 1 kilobyte inline threshold for NFSV3 worked out great, but it's not working so well with NFSV4. A large number of RPCs during operation require long messages, which adds a registration and validation. And for position 0 read chunks, it adds that round trip that we don't want. And finally, back channel operations don't have any need for RDMA. They don't have any direct data placement payloads. But still, they can be larger than 1 kilobyte, in which case they would fall back on long messages, and that would require chunks, which we kind of don't want. So we thought a larger inline threshold would allow us to address all these issues at once. Slide 9. I picked 4 kilobytes because it's the size of a page. It's 4 times larger than what we have. And more importantly, I think it can be supplemented by optional features, extensions that we want to add to this that would allow exchange of larger inline thresholds like 8 or 16 kilobytes and the ability to string individual 4 kilobyte sends together and to make longer messages, make longer RPCs. We didn't want to go too much beyond 4 kilobyte because that might restrict the kind of hardware or operating systems that could use this, and also because larger receive buffers on servers and clients would pin lots of memory. And we kind of want to restrict that without having to rely on the complexity of a shared receive queue. The bottom bullet point, I haven't seen a lot of benefit for payload bearing operations larger than 16 or 32 kilobytes going with only sends. So I didn't think that having an exceptionally large inline threshold would be very useful there. So 8 or 12 or 16 kilobytes seems to be about the limit of usefulness for that. And if we're doing message continuation, then we don't even need to go that big. 4K plus message continuation would probably, solve all of our problems. I think that's the last slide. Oh, no. We considered adding remote invalidation to the base protocol. The first bullet on this slide describes what remote invalidation really is. It means that instead of the server using a send to convey an RPC reply, it would use send with invalidate, and it would specify one tag, one memory region that the client RNEC invalidates before the receive completes. And then our clever implementations, client implementations might basically register only one tag per RPC, and that would mean send with invalidate would be able to invalidate all of the memory regions associated with that RPC when it completes, making that very efficient and mitigating the cost of doing the client doing the invalidation as a separate context switch. Question? David?
Yeah, let me do this, then I'll go back to the inline one later after you're done. Actually, I'm going to look at Christoph and bug him. My recollection from dealing with remote invalidation is that base RDMA protocol support for this is variable. In particular, ICER had to be redone to not require send with invalidate. And Christoph may know the details of who the problem children are.
It's even worse than that. So all the protocols support remote invalidation as long as you use fast registration FRs. So if you use different types of memory registrations, it doesn't work. But the fortunate part is if we design a new protocol, which I think RPC over RDMA version 2 would be, there's a neat little hack around it. And the hack is based on the fact that the client, or the entity that's sending a remote invalidation request has the ability to check if it actually happened. So basically, whenever the client that is doing it sends it, it must support it itself on its side, and the server can simply ignore it, and it will notice that the server ignored it.
And that is exactly the hack that went into ICER. If you look at ICER, you'll find approximately what Christoph described, namely, if you want to use a send with invalidate as an optimization, you can, but you have to check that the invalidate happened afterwards because maybe it didn't. So just heads up. This is not 100% reliable. It is a use optimization when it works.
Right. So yeah, we sort of understand those issues. Actually, flip to the next slide. So this is basically a Wither remote invalidation in V2 slide. Why we decided not to go with it in the base protocol. The basic support doesn't require any XCR changes. What SMB directed, for example, is they said, okay, after this protocol version, remote invalidation is always on, meaning that the server may use send with invalidate, and the client has to check for it, check for invalidation. I think the reason why we don't want to do that here is it might disenfranchise different types of memory registration modes that we want to continue supporting, like FMR. I don't know if it works in user space or not. So I think we do need to have kind of some kind of signaling in the protocol to do that. And we could add that in the base protocol, or we could rely on an extension. And right now we're taking the extension approach, which Dave Novak will talk about in a minute.
Okay, sounds good. And the other thing is this your last slide?
It is.
Okay, can we go back to the 4K slide?
Yes.
All right. All right. Would somebody tell me why the answer is not 8K?
I thought I explained Why? It's
I see there might not be much benefit past 16K. 4K is getting to be a bit long in the tooth, particularly if you want to send a 4K page and some other GORP. You might want to have a payload large enough to carry the 4K and the GORP. And I would strongly suggest going for 8K unless you've got a really good resource consumption argument against it.
Yeah, we do. It's the receive buffers, large receive buffers. And also, for HCAs that have a small scatter gather limit, they wouldn't be able to do 8K. This would be the minimum. This inline threshold is the default and the minimum value you can set.
Okay, you just answered the question that there are HCAs on which 8K is not implementable. Okay.
I don't know of specific ones, but that's my assumption.
Sorry, it is believed that there are HCAs on which 8K is probably not implementable is a reasonable reason not to go to 8K, because looking at it from the abstract of where the operating systems are, if I'm just looking at it from an operating system perspective, I would go straight for 8K to get some future proofing. But if you've got hardware that is going to struggle to cope with 4K, then 4K is a reasonable answer.
And there's a lot of future proofing in this, actually. Message continuation will give us larger ability to send larger operations with just send. We also have the ability to have implementations exchange information at the initial connection that says, oh, I actually can do 12K or 16K or 32K inline threshold.
Right, and where I'm coming from is that file systems tend to have a native block size that's no smaller than 4K. It's often 8K. The ability to do one file system block inline is a major win.
We would need to do more than 8K for that.
Right. If you did 8K, you'd have the 4K block inline.
Sure.
That's a reason for doing it, and that gets you somewhere. I'm gonna look at Christoph again to figure out where Linux is on 4K versus 8K block size. I know anything smaller than 4K is silly. I don't know how close they are to going to 8K across the board.
Well, pretty much everyone's using 4K blocks, but then again, we have this cool nifty concept called extends that gives us a variable size block. So databases still like to do 4K IO a lot, or something.
Actually, 8K.
Well, it depends on the database. Yes. There's more than the one. But as far as the file system concerned, it's basically any multiple of 4K.
Right. So, we could go back and visit the question of, what hardware would be disenfranchised by using an 8K or even a 12K default lower bound.
Based on what Christoph said, please go back and look at 8K, because it is just for a single block operation that requires no RDMA work. You do the send, you get the response, and it works for a single block read or write, is a major efficiency win. So please go have a look.
Right. And I think you're asking for the ability to do an 8 kilobyte IO, not to send 8 kilobyte messages. We need to send. What
I'm asking for is, I'm asking for an NFS read or NFS write for which the data read or written is 4K in size. You're going to need an 8K inline to get all the GORP in there.
5K. Yeah.
Yeah. Right. But five's a silly number. You want it. If it's not 4, the next interesting number is 8.
So there's actually another aspect to it, and that is being able to not copy that data. And for that, we really like it to be aligned. So basically what we would like for that scenario is have your actual file payload aligned, which currently with RPC RDMA is a little difficult.
I think Dave has some slides on that he's about to talk about. So
great.
I'll let him go there. That's it for me.
Okay. Can people hear me now?
Yes.
Yes.
Okay.
Let's see for how long.
Anyway, so I'm going to talk about a number of extensions that have been proposed in the context. What?
Go ahead.
No, you go ahead. Let's see how this goes.
Okay. So I'm going to talk about 3 documents, 3 IDs that I have out. And one is XCarX, which is a way of transferring transport characteristics that addresses issues with regard to invalidation and with regard to not negotiating, but deciding on buffer sizes, and then RT issues, which is basically an informational document, and RTRX, which is another extension. So anyway, so I want to talk about those extensions. They're all in the context of version 2 that Chuck has described. Let's go on to the next slide. So the overall goals of these documents are 2. One is to recover the valuable things, and there were valuable things that were mentioned in RFC 5666, but were never filled out, never implemented, and had to be dropped in the transition to RFC 5666 bis. One is transport characteristics reporting and exchange, which was implemented by a separate RPC protocol, but here I've made it a part of an optional extension in version 2, and also direct placement without explicit RDMA ops. That was RDMA message P, but had to be dropped because it was never specified and thus never used. But it was a good idea. And second, what we wanted to do is get the performance-related features that have been proven in other similar transports, but are not available in version 1. And now is the time to get those. That is remote invalidation and message continuation, both of which are valuable. Let's go on to the next slide. So I have an ID, XCarX00, that provides a framework to describe transport characteristics, and it's a generalizable framework. So enables some performance improvement. Now, it enables one thing is determination of whether you have remote invalidation support. Now, from David's presentation, I'm not sure whether that is enough. He indicated I got the impression from his statements that maybe it might be in a situation where you might be in a situation where we're at a situation where sometimes we're remote out. But I'm assuming that either you can agree at the start of the connection whether it works or it doesn't work, and that you would transfer that information, and then you could act on that basis. The other thing that it would allow is it would allow you to determine whether you had other features like message continuation or send-based DDP, which I'll talk about later. Also allows you to have larger than 4K or larger than, if we decided that the default is 8K, it will enable you to have larger than 8K. So in any case, this should be determinable after the connection is determined, and therefore you could have larger. So I think, if you want to transfer 8K, you probably need 9K or 9.5K to do that in one shot. And so you would probably need, even if you decide an 8K, you would need this facility to get it something larger. So because different clients and servers would have different message that they transmit, there's a part, that involves authentication, stuff like that. That might be different for different people. So they need that fixed, that part, plus the 1K or the 8K block. So probably people would need more like 9K. In any case, next slide. Hello? All right. So then I had this RT issues. Now, there's been discussion, some on the mailing list, and some was at the when we had this this conference call about the round trips. And I've heard some people say that there's 4 round trips, but there aren't 4. It turns out, hello? Yeah.
Yeah. Sorry, Mr. Novak. You just went garbled again. Hey, the AV guy says you can hit the icon and disconnect the audio and reconnect the audio without resetting your whole session. Try that, or else do what you did before, which cleans up everything. Sorry, Dave. There should be a worldwide organization that works on these internet issues. Christoph isn't laughing.
Oh, he is. That's the problem.
That's him laughing. It's the German. Oh, Austrian. Sorry. The other part of you. I'll say when it works, it's amazing. How do I, let's see here. Sorry, we're waiting for Dave Novak to rejoin.
And Lorenzo is watching.
Yeah.
I'm back, I hope.
Yes, you are. Hold on, Dave. Chuck, do you want to jump in now? Chuck Lever, we've been waiting. Chuck Lever has a question. So
Chuck Lever Oracle. It's not a question. As soon as I have some technical objections, which Dave already knows about, Mr. Novak already knows about. So I'd like him to get through this slide, and then we can have a conversation, a dialogue about some of these bullet points. So go ahead, Dave.
All right. So this is about the document RT issues. It's focused on the round trip issues within RPC RDMA V1. It's focused on simple common cases of such as 8KIO. And I want to know how bad the problem is and whether it can be fixed without writing off V1 and taking a completely new direction in a V2 or V3. So my conclusions were that 3 round trips are needed when explicit RDMA operation is used. Well, actually, it's probably only in the case of RDMA read. I think that's maybe the nature of Chuck's objection. Anyway, there is a latency issue.
That's one of them.
Yeah, there is a latency issue in the case of write, which is an RDMA read. And you have in that case, you have 2 nested round trip latencies. And also an extra instance of server-side interrupt latency. And we'll see that in some detailed slides that Chuck has helped me with, because my original versions weren't right. And now I think these are correct. These ones that I'll be presenting next will be correct. And yeah. All right. So my overall conclusion of this in this study is that the performance issues that we have can be addressed in the framework of the existing V2, which is interoperable with version 1. So here you have, let's see. Okay, next slide. All right. So this discusses doing 8K right. You have in two ways. One is using it with explicit RDMA versus send receive into a large buffer. So you register the memory. Well, that's, now that registration is not needed if you're doing send receive. And then you send the RPC call. That's the same. The internode latency, that's the same. Server interrupt latency, that's the same. Then you start an RDMA read operation, which is not needed if you're doing if you're not doing an RDMA operation. Then there's an internode latency to retrieve the data from the client, and an internode latency to get the data back. So that's the nested internode latency. And then there's an additional server interrupt latency. So these are all the things in red here on the right side are things that are not necessary if you're doing, if you're not doing RDMA operations. And so that's the case for write, which is the particularly bad one. And then on to the next slide, which is read, which also has an extra overhead, but it turns out it doesn't have extra latency. So I think I can go, I'm not going to go through reread this in detail, but on to the next slide. So the observation is that there's a bunch of extra work involved in providing DDP using explicit RDMA operations. It's not as much as copying the data, but it isn't free. And I think my impression is that if you read RFC 5666, it gives you the impression that this is so wonderful, which is pretty good, and it's essentially free. But yes, hello.
Just chuckling here.
Yes.
Okay, right. So I think if you read RFC 56 bis, it takes a more measured view that this is good. This is better than copying the data. But there is a noticeable cost, and if you can get the benefit of direct placement without copying the data and without doing RDMA, then that's a good thing. So I think it's best to avoid copying without using explicit RDMA operations. On the send side, the implementation can avoid using send buffers. Often there's been discussion on the main list of using send buffers, but you don't need to do that. If you send data from where it is, you're ahead of the game. And on the received side, you need direct data placement without explicit RDMA operations. So my conclusion is that RDMA message P was on the right track, but we had to drop it because it didn't really exist at that point. So I think the essence of that approach can be obtained in a different form, and that's what the most of this talk will be about, how that might be done. On to the next slide. So the additional round trip involved doing an explicit RDMA operation in addition to basic sends and receives for RPC. That adds additional round trip, and also, although there's concern about the acts, and there was some discussion about unreliable datagram, that doesn't add to latency. And so I decided that wasn't worth the effort, and it is a lot of effort to try to do that. So I figured that explicit RDMA operations are not needed in many common cases, and that will be on to the next slide. So the basic approach here is to be able to avoid most of the common cases in which we use explicit RDMA operations. One is to do DDP. And later I'll show how you can use send-based DDP, and that's using it on the same idea of message RDMA message P, and in the cases where the message is too long for the buffer, you can use multiple messages. That is message continuation. Also, the availability of message continuation is useful even when you don't actually have large messages, because you have to register memory if there's some possibility, even if it's very small, that there will be a large message. Even if the probability of that is 10 to the minus 9th or 10 to the minus 12th, you're supposed to have this thing. You're supposed to register this memory, which you go to the trouble of registering and deregistering, even though the chance of you using it is very small. So the result of this was in RTRX is that there's two optional features in a single extension. One is message continuation, and one is send-based DDP. And the implementation may support either or both of those. Next slide. Okay, so based DCP, we use the same basic idea as RDA message P. You place data in an area with the required size and alignment. And given that we're talking about file systems here, that's usually somewhere in a position in something that's like a buffer cache. That's on an 8K thing on an 8K boundary, or 4K pieces on or 4K boundaries. And often when you're reading things that are longer than that, you're okay with putting them, if you're reading 64K, you're okay you don't need them to be in a contiguous 64K piece. You just need them to be in 8K pieces. So this uses the same basic idea of message P, but the differences from RDMA message P is this is treated, RDMA message P was basically, gee, this odd optician, and this treats it as basically another instance of direct data placement, and it's governed by the ULB, and that clarifies things and makes it more manageable and more specifiable. The sender has knowledge of the receiver's buffer structure, and that's where the XCAR-X comes into view. By making that information available, he then has the information to figure out exactly where he has to, what kind of fill or padding he has to place to put it so the message winds up, the direct data placement, directly placed data winds up in the place it's supposed to be. And this supports DP for data you're writing or for data you're reading. Both of those are done. And in the case of data you're writing is more important, as we've seen. Next slide. Now, talking about buffer structure, I've built this on the idea that received buffers will use scatter-gather lists. Now, in the case of where you're reading 8K thing, you'd have some piece of data which is not directly placed. That would have your most of the compound, all the things that are not directly placed, that can fit usually in 1K or 1500 bytes. And attached to that would be an 8K directly placed buffer that's aligned. So some likely buffer structures that we'd have is like 9K, 1K for the payload segment, plus 8K directly targeted buffer, or 5K if you're using 4K buffers. But those are, I think, the kinds of sizes that people would typically use. Although there is an option that they might use 16 or 32K, and that is a choice that implementation will make. And I don't know, that's not fixed in the proposal. But the expectation is that people will typically use something on the order of 5 or 9K. The buffer structure is available to the partner as a transport characteristic. That enables him to compute where the alignment of things and send things so that when they are received, the directly the 8K piece will wind up in the aligned 8K area. Next slide. So because I've done this, I've had to create a new set of DDP related data structures. The new optional message types that are defined do not use existing read and write chunks. But the provision is made to use old style DDP with explicit RDMA operations. The new message type requests include an optional reply chunk that's needed to support cases in which message continuation support is not present or cannot be taken advantage of. Now there's a new approach to DDP. Each message, whether it's a request or response, indicates where the DDP eligible data in that message is located. And then furthermore, the request indicates how the DDP, separate set of data structures, how the DDP eligible data in the response should be placed. And this structure provides more flexibility than the current write chunk mechanism. And with message continuation, the DDP info is only present in the first send. So if you were sending, let's say, a 64K IO, the first segment of that, the first send would have all the DDP information for the whole 64K IO, and it could cover multiple buffers, 64 or even 256K if you were doing enough message continuation. Okay, next slide.
Can I interrupt you?
Yes.
Christoph here. So on the send side, as in talking from the client to the server and writing data or the respective back channel operation, I agree a lot with the approach up to a certain threshold. And the reason why that threshold is important is that with this scheme, you need to pre-allocate buffers up to the inline size you want to support for every possible outstanding request on the receiver. So for something that's reasonably small, where reasonably small is implementation defined, perfect approach, and it's the same we do in NVMe over Fabrics. It's the same that ICER can do. It's the same that SRP is adding for the 2.0 version. So agreed. I don't really understand what the benefit of this is on the reply side, so on answering an NFS read, because the actual RDMA write and the send are pipelined anyway, so you don't save a round trip, and at the same time you impose that whole buffer management scheme onto the client. On the server, it's not a bad thing because the server is, a lot of the server is about managing buffers, but on the client, lots of use cases in the NFS client involve transferring data into buffers not controlled by the NFS client. So just to give the simplest and most obvious example is direct IO, random user space application buffer, and the database that's using it will be very unhappy if you impose a copy on it, because that's actually even worse than NFS over TCP/IP in some implementations. So for that side, there's a reason, for example, why we didn't even specify inline data for replies in NVMe over Fabrics.
Okay, so this is an option, and if it's not appropriate, you don't have to use it. It doesn't eliminate the ability to do this via RDMA operations. So in any case, I can see that there's certain cases where you don't want to do this, but it's specified symmetrically, but that doesn't mean you have to use it symmetrically.
Well, let's frame it another way, and we don't have to answer this now, just for the next version of the document. What are the use cases for doing it on the NFS read? For the write, totally agree, very useful, very important. But for the read, it's very hard to find a use case where doing this actually is an improvement over doing a registration and a send with invalidate.
Well, I don't know. I don't know, and I think people will experiment to find that out. But
Chuck,
there is an overhead of doing these RDMA operations. So I just don't see any reason that I think it is less overhead, but I don't know by how much, and I'm not sure how it balances out for particular implementations. I think we'll just see.
I'd like to make a comment about, or attempt to answer Christoph's question about what are the use cases. I would like to see some too. One that I think is addressed in your ID is the reply chunk. But I think there are reasons why that isn't really a significant issue. The reply chunk is used because the client registers a reply chunk when it thinks that the maximum possible reply size is going to be larger than the inline threshold, and often it isn't. So in that case, if you have the ability to send the replies with a RDMA send instead of using the reply chunk, you might be better off. But I think I can argue pretty convincingly that the reply chunk problem is addressed with either larger inline thresholds or message continuation. And so send-based DDP on the reply side is probably overkill. Anyway, yeah, we can take this offline.
Okay, sure. All right, so I guess we're on to the next slide. Next slide, or?
We're there.
Sorry, there's a delay on the slides being remote.
All right,
see it
yeah,
yet?
sure. Okay, yeah. So these are new DDP related data structures, which are different from the read and write chunks. So first of all, these are the structures that describe when you send a message, you say, where is the data? So this applies both to requests and responses. And each of them has XMDDP M items, and which contain the displacement of the item, the length of the item, and location information. And that location information is a union of which is described in the next slide. And to enable this to accommodate both old and new style DDP, a switch union is used. And that allows new header types to be used by those that don't support send-based DDP. So for example, if you're just supporting message continuation and haven't supported DDP or not supporting it in a particular direction, you can use these new message types. You would have the new DDP related structures, and they would accommodate doing explicit RDMA if you want to do it in a particular direction. Okay, so you have a case for explicit read-write, in which you have an array of RPC RDMA 1 segments. You have a TBSN case, which gives you an offset of the start of the item in a DDP targetable buffer segment, which are numbered. All the buffer segments within a particular request, which may consist of multiple sends, are numbered, and you just number which one there is, and that tells you where you go. And that's for the send-based DDP case. And also in this case, there's a few cases which are only used in the response case. You get an explicit item when you presented sometimes you send the about information in the request about a potential DP target allowed, which isn't realized because either it doesn't exist or it's too short. So those are like getting back chunks that have 0 length. Hey, you send me this, but I didn't use it. All right, on to the next slide. So there's also separate in this model. There's a separate sense of DDP response direction structures, which when you send a request, they tell you where you place, where you the responder should place the data that is DDP targetable. So because this was, these are organized into sets so that you can say, I can have a different set for each particular NFSV4 operation. So this allows you to say, well, gee, here, if, you don't have to deal with the fact that you might have, if you have cases where one op may or may not return a DDP targetable, a DDP eligible item, you can isolate that to a particular operation. And each set contains items that gives you the minimum length. Now you can specify in this model, you can specify only that DDP eligible items above a certain size are sent DDP, where others are done in line. So that's more flexibility than we've had in the past. Okay, so next slide. So this is also a switched union. You can say, put this in explicit location. You can say you have the choice of doing it, or you can say you have a choice of doing it based on the side. You can say, well, up to this size, put it in send-based DCP, or above a slide, like a megabyte or something. You may do this by DDP, either your choice. And okay, next slide. So also, beyond the send-based DDP, which is the biggest part of this, there's also message continuation. That allows a single request response to split into multiple sends. And there's less need to use it when received buffers are larger. They're now 4K, or maybe 8K has been suggested. But still, there will be cases where you don't know the response. You think the response is very, very likely to be 8K, but there may be cases where, well, you don't know for sure. You can't prove beyond doubt that it will be under 8K. For example, get at her. Say, well, there's no way of knowing for sure, absolutely for sure, that someone is not going to have a very long owner name, for example. There's no way of proving that. So you may be forced, if you don't have continuation, to register memory when you don't want to. So anyway, message continuation. So the approach taken is to number the segments of a message. So the initial message has the number of segments, and then the count has to be known in advance to support CRED management. And that's the hardest part of this, is CRED management for message continuation. Next slide. So message continuation requires 1 credit per RDMA transmission. And there was some language in the spec, which I think still may be around, about tying credits to RPC messages or RPCs, but I think that will be gone, at least for V2. And when sending a multi-transmission request, you must have enough credits to be available on the responder to receive the complete request. And if they aren't available, you can use a position 0 read chunk, since this is an optional extension. You don't have to use it. But in most cases, you probably will maintain enough messages so that if you have to send something that uses 2 or 3 sends, They will be available. You'll be able to send those if you have the appropriate credits. Next slide. Now, when you're sending a request, which might need a multi-transmission response, the requester needs to pre-post enough receive buffers to receive the maximum size response. If that isn't possible, if you can't do that, you have to do a reply chunk. And the number of posted receives, and when he sends the response, he tells you how long it was. So that means either he used up the ones that you pre-posted, or he used less. And when he used less, you can recycle those. If you said, "Oh, I've pre-posted 4 receives," and he only uses 2, those 2 are now free for use once you receive the initial segment of the response. All right, on the next slide. So this extension has 3 new message type. There's one to send requests, response, and continuations of either requests or responses. And those can be supported even if you're not supporting any of the new features. And also, you can determine. There's a lot of the spec deals with determining how you can determine what side the other side supports, whether he supports message continuation and to what degree, what's the maximum number of message he can combine in a message, and whether he supports send DDP. And you can support these new message types without supporting any of these features. And I will expect gradually people would implement these features. And in any case, you have the transport characteristics give you the ability to determine what you have and for you to advertise what you have and determine what the other side supports. Okay, I think that's next slide. So this is my discussion of where I think we go from here. We should be going from here with updating RDMA version 2. First, I think we need to assess where we are. I'll present my own assessment, and I want to hear from others. We want to make some decisions about the directions for RDMA. We want to address the near-term document issues, and we better understand RDMA performance issues. All right, let's go on. Next slide. Okay, this is my assessment about where we are now, and if other people have I think we have time for other comments. So I think the work in clarifying version 1 is now pretty much complete. And this was a necessary chore, and I want to thank Chuck, Tom, and Bill for getting this chore done. And there's been some disagreement about how necessary this was, or whether we should have done this or should have gone. Anyway, it doesn't matter now. We've got that done, and we now have basis to proceed to improve it. Now the XDR shackles are off, and we can look at what is necessary to proceed further. And in doing that, it's important not to interfere with ongoing version 1 implementation work. So I think that, therefore, that's the best framework, is to use the version 2 framework, which explicitly is able to interoperate with most version 1 operation with existing version 1 implementations, but extend them. And next slide. So the working group needs to make a decision about the future RDMA direction. First of all, it's decided that RFC 5667 BIS is needed, and work has started on that. The working group has not really yet made a decision. I hope it will make a decision soon soon about version 2. And I think Chuck's done a good job of producing a framework that provides extensibility. And so I think we should, proceed with what's necessary to get that to be a working group document. Now, I've been assuming in this talk that that's the framework that we will use for these extensions, and I've built these IDs on that basis. So I think implementers need to decide on the focus of their efforts. Some people will be trying to catch up with the work in 5666 BIS, and some of them may be looking more to go beyond that. And so those who are post version 1 focus need to decide what existing extensions are important to them and implement those, and also whether propose new ones. And I'd like to see whatever works, what other new extensions people have in mind be proposed. Okay, next slide. I think we're at about the end of this. Okay, there's a couple of near-term documentation issues. So I describe this as a tower of IDs. We have my RTRX is an ID that's built upon XCARX, and that in turn is built on draft CEL RPC RDMA version 2, which is also an ID. And so as a result, we have a tower of 3 IDs, one built on top of the other on top of the other. And I think it would be good. First of all, none of these documents have had much working group discussion and review so far. And now that the version 1 documents are done, I urge people to look at the documents related to version 2, starting with the with draft CEL RPC RDMA version 2. And as that process proceeds, I think the work group needs to consider making the lower levels towers, starting with version 2, into work group documents. I'd also like there to be further discussion of XCARX and get that decided as a working group document. Once that's done, I think we'll have some further discussion. Yes.
Chuck Lee Oracle. Let me make an interesting proposal. Let me bounce this off you. I've actually written reviews of XCARX and RTX, and I will post those later this week. But it occurred to me that because so many subsequent extensions of version 2 are going to require transport characteristics, it might be a good idea to fold XCARX into version 2 now, combine them into one document, and provide XCARX as a facility of version 2 that other extensions can build on. What do you think of that idea?
It's okay with me, but I hadn't been assuming that, but I think I don't. If you think that can be done relatively easily, I think that would be a good idea.
I don't think it'd be hard to do. I mean, from what I've read of XCARX, it looks like it's fairly complete, and it's not a long document, and it seems to fit within the mission of version 2. So philosophically, I don't have a problem doing that, and I think it would make much of this a little easier.
Okay, my concerns were not philosophical. My concerns were, sort of the work of if you think it can be done fairly soon in terms of actual document manipulation, I think that'd be a great thing to do.
All right, we can talk a little more offline, but yeah, I don't think it would be longer than a few days of editing. So.
Okay, that sounds good. And that would simplify that. Then when that was done, then that single document could be thought about as a candidate for working group status. All right, I think that's the end of my slides. I hope. Oh yeah, okay. All right, I do have one more slide. Okay, so this is my impression of where we've been with RDMA performance. We had a situation in which we weren't sure whether our performance issues were protocol weaknesses or implementation problems, and that uncertainty made it hard to make progress. It's very hard to tackle big implementation issues if you might really have an underlying performance protocol issue. On the other hand, it's hard to address the protocol weaknesses if it might really be implementation issues. As a result, I think, so anyway, in any case, I think this set of extensions address all the protocol of performance issues that I know about. And if people think there are other ones that should be addressed, let me know. Let me and the working group know about that. If, on the other hand, I think we have addressed these, then it's time for people to work about your implementation issues and trunking. In any case, I hope that we're now on the work to having better performance. Okay, that's the end of it. Questions?
I don't think so.
No questions, Dave.
Okay. Bye.
Thanks.
I just recorded it my session. So
Yeah.
you guys are better.
And I think we're more desperate.
Yeah, I'm great.
So I think the next one up is the flex file layout. And it's me. Status, I'm in the midst of applying the last round of reviews. Basically Dave's. Wait, oh, I did the wrong one. That one went fast. Oh, I think I've mixed up my slide titles. This is the layout types document. And it's the one where I've just run out of time of doing the updates. And
I told you not to have that last Hefeweizen last night.
was it me or was it you?
Oh, right, all right.
All right. So this one is actually the PNFS, the Flex Files one. And, and see the bottom part is right. It's just the title is wrong. I'll get new slides out. The main thing is I've got a round of reviews from Dave. The main issue is the FDS state ID. It's basically not usable. So for the loosely coupled situation, which is V3, there's no need for it. For the 4.x, it doesn't make sense because you can't pass a state ID if the MDS and the DS are not speaking the same language. And then it won't work for tightly coupled because it's global. And the upshot of it is we could modify the XDR, except there are implementations out there that there's 3 or 4 of them. And no, we're not going to do that. And we could deprecate the field in the document, and that's the path I'm going to take. We're going to explain why it doesn't work, and we're going to lay the groundwork for if someone wants to do a new layout type that fixes the issue, they can go do it. That's the beauty of the layout types. They're pretty cheap. Yeah. So this was the corner I got painted into last year, and I didn't see the out until recently, and so this is the path I'm going to take. And there, I've gone through 20 minutes of slides. Any questions? Any comments? I think Dave left. He might have been the only one who wanted to talk about this. No? In that case, Andy, I think you're up.
Okay.
Look at that. All right. Kind of first try. Andy Adamson on NetApp. This is a quick little overview of some work I've been doing to implement session trunking. I started based on the work on the multi-transport feature that Trond Menkelbust added to the Linux client, which I'll describe a little bit later. But basically, keep it in the same slide there. So the second bullet, we have the issue here is for PNFS data servers, the get device info multipath 4 gives you a list of potential session trunking addresses. But there is no such protocol feature for the straight ahead NFSV4 non-PNFS server or MDS. And so the question here is, how does the client discover a list of potential session trunking addresses to test with an exchange ID? I brought this up when I was showing my Linux prototype code at the June Bakeathon. We had a meeting. Next slide. So for me, I took a look out at what are the options for multipath today. MPTCP is a good option. SETP is another one. And then the RPC layer Linux feature that I mentioned that Trond put in, which gives you multiple transports per mount. Next slide. So MPTCP is actually a very good solution if you're just using TCP. A couple of issues. One is that the NFS server and client see only one TCP connection, which for the client is great because it gives you sort of automatic session trunking. And the server can be an issue depending on how you assign resources. Sometimes some servers assign it per TCP connection, and if you're multiplexing underneath, that can be an issue. Also, if you're using this for session trunking, you don't have any support for other transports. It's an RDMA. But it does an automatic detection of multiple network interfaces. There's been a lot of work on client discovery of addresses and how to respond to different topologies, load balancing, etc. So this is actually a pretty good automatic way to get session trunking. Next slide. SCTP also has some of the same features. Again, it was originally for HA, and now new load sharing for performance that's similar to MPTCP. The difference is this is a newer protocol that needs some work. Performance, even in 2016 being measured, is only slightly better than TCP. And it does require client discovery of server multipath addresses because you have to specify them when you make an association. So next slide. The multiple transports that I mentioned is just a new feature, and you can go ahead and try to connect to another IP address or another transport address, and then add that transport to the RPC client, which sends everything to a mount point. And you can plug in algorithms. Currently, the only one is round robin. So for this to really work as well as what MPTCP is doing, we need to be able to respond to network topology, etc. So there's some work that needs to be done there. But we are in total control. The NFS layer is total control of this, and so there's some advantage to that. Next, but the client discovery. So here's the three ways that we've seen. One is for the client just to list the host names on the mount option. The next is use a DNS record, and the last is to extend the FS locations, which is why I'm bringing this talk to the group. Next, please. So multiple host names on mount. This is supported by Solaris, although at the Bakeathon, the engineers there just expressed their dislike for this option, as was also discussed on the Linux kernel list for the same reasons they disliked it. There's another mount option to support. There's no response to the change in network conditions. You have to talk to all the clients, etc. So this is not a very popular method, and does not look like it will be supported in Linux. Next. DNS for multipath. You could use a DNS A record or a special trunk record, but DNS is really meant to be more static, I think, than what we're looking at here, because when the server changes its NICs or the network topology changes, then it takes a long time for these changes to either occur in the DNS realm itself, and also to make it out to the clients. So next. So then this brings us up to FS locations. Currently, FS locations really is per file system, so it's not server wide, which is session trunking is. It does have a useful replicant definition that you can have a set of servers with the same path, and so you could use that for session trunking. But when it's per file system, most of these addresses will be to different replica servers. Next slide. So the solution that we're looking at is potentially to use an NFS locations or locations info replica attribute on the pseudo file system, which doesn't migrate and it's not replicated. I guess it could be, but I don't think it ever is. And so you could define this as being applying to the whole server and use this FS locations functionality to express session trunking addresses to test. Next slide. So the question is, do we want to do this? Do we need to specify a means? Is there something I've missed? Should we just use MPTCP? It gives us a lot of the way. And then again, is this FS locations info on a pseudo file system a reasonable approach? And so should I approach it? So questions.
Lars Eckert, I can't believe I'm going to the mic in an NFS session.
There you go.
Almost
Lars,
like I'm
how
looking
you
for a
doing?
storage company. Man.
Step away from the microphone, Lars.
That's right.
So I was one of the guys who originated MPTCP as a research project, and,
Yes.
and so I followed it a little bit. They are currently talking about an extended API for new apps that want to use it, where the app, the NFS implementation, would get pretty direct control over what data goes on which subflow, which connection.
Oh, great.
So you might want to chat with them, because I think they'll be pretty open to learn about your needs as an advanced application.
Yeah, I was very impressed with the progress. I went to the MPTCP talk, and that's why I actually added this bullet here, because when we had tested the implementation in Linux, we were going, I don't know, but I think there's a lot of work happening, and I agree. I guess the one thing is, thinking of RDMA.
Yeah.
And so what do we do there? So maybe a combination, but but still the idea is that we would have to, then maybe discover client addresses, server addresses.
Exactly. And you get so SETP actually doesn't do, so the Linux implementation and the FreeBSD implementation allows parallel paths to be used at the same time.
Yeah.
The standard only does failover.
Right.
So
it's coming up. Yes.
Yeah.
Everything's new in SETP.
Yeah. The other thing, if you bring up the RDMA issue with the MPTCP guys, I think they would be pretty interested in that, because they're thinking about data center stuff, and so RDMA is pretty hot right now, and they might go off and try to work this out for you.
Well, good, but so that's great, because the underlying technology is moving forward, and we don't have to do it. That's wonderful. I'd love that, but it still brings up the issue of how do we get clients to discover server addresses, which I think we'd need in any case. So. The question is, I guess I'll propose this in the list.
With MPTCP, you need one.
One.
Right? Which is exactly the state in
So
now.
it discovers everything for us.
Right. So with MPTCP, when you establish the TCP connections, there's an MP capable flag that the client sends, and then the server, if the server speaks, it can then offer its additional addresses in band, and the client learns them, and then each side can initiate additional paths, subflows in MPTCP speak.
So that's totally automatic.
It's totally in band. You just need the one to get you started, and you already have that.
All right. Well, good then.
Question about that. Can you have multiple connections between the same IP address?
Microphone, maybe.
You can repeat my question.
The question was whether there can be multiple connections between the same IP addresses. For performance. I think so, but I'm not sure. So MPTCP has this plugin module, which they call the scheduler, which is the thing that decides when you want to send something, which of the things you put it on.
Right.
And there's a few of them that are defined. It's like first come first serve round robin, kind of like the RPC stuff you talked about, and they are pluggable. So that there could be something that allows you to have more paths and then schedule them differently.
All right. Well, that sounds like a good approach. I'll propose to that. Yeah. Great. So I guess that answers my question. Thank you.
No, thank you. That's it.
That's it?
Yep. Unless we want Christoph to go again.
No. I mean, yes, but no. Okay, we're finished with the presentations. Any closing comments from anyone? I think we had some discussion and some follow-up items I've written down. I want to reach out to a couple people to get some information on some next steps on the follow-ups. Thank you very much. If you haven't signed the blue sheets, sign the blue sheets. There's one. Lars has it. He just put us over the edge with that one signature that ensures we actually have a meeting room at the next IETF. Thank you, Lars. Yeah. Yes. All right. Well, I plug my thing in. Okay, I think I'm gonna leave it plugged in, and I'm gonna charge while I can. I did not plan ahead at all.
Yes. Because that's really sort of for using it to speed data center, what's really there's a lot of work on it. Yeah. So to be able to show you I'm here till Thursday. Okay. Yeah. So there's the professor there is already going on the tour. There's a bunch of students that don't.
I don't care. Basically, you can make it 4 p.m. and perform with the mail on the block side.
He's all doing their model.
They're all here. Right, what section? They're meeting on Wednesday, too.